conference, that's downstairs, that's not us. So this is Influx here. How was lunch? Good, yeah? Good job. You know, I had a lot to do with that. No, I didn't have anything to do with that, so, you know. Well, I thought it was interesting this morning. I'm just sort of, it's going to be the witching hour. Steve's got the tough thing of taking you past lunch, but maybe before Steve gets up, just sort of thinking back at this morning, in case you forgot what you've seen, is you know, how to find the God particle with InfluxDB, I think was the name of the talk from CERN. And then we learned how to go and save the planet, obviously with Tado, keeping the chrono giraffe from crying, and you know, don't forget obviously Paul and worrying about flux. So we've come some way, and for the afternoon we're going to change things up a little bit. Steve's going to start talking to us a little bit about creating impactful visualizations, and it's very much in the capital market side of the world. So over to you, Steve.
There's actually two of us here today, so just want to say thank you to InfluxData for giving us the opportunity to talk about how we've built a big data visualization platform on InfluxDB. We've been working for them for many years, and it's a great relationship. As I mentioned, this is my colleague in CTO and potentially my work husband, Pete Williams. I'm his work wife. Me and Pete, I think we've been working together now for 10 years, and Pete's actually, you're from round here. This is your manor. He went to school around here. He's been working his whole life in the capital markets. I've been working in the capital markets for about 18 years now, and we know the square mile. We've been to every client in the square mile. If we don't know them, and then it was a couple of years ago, wasn't it? We kind of got lost going to a client, and we were incredibly embarrassed. And we went, well, we're not actually lost, are we? We said, because we know where we are. We know where we are right now. And we know where we've been. We know where we came from, and we know how we got to this point here. And we actually know where we're going. There's just a bit of data we don't know and we've got to work out, but we've got enough information to get us to where we need to go. And the reason I tell that story is because we've seen lots of visualization platforms. We know how they work. But to me, the difference is the use cases. So the use case for this platform, Pete, if you can just spin it up, is ITOA. Now, what I'll just do is, if we just wait for it to spin up at the top, Pete, if you can just zoom in when it comes in. So what we're about to see is we've got down this side here, we've got a raft of servers here. This particular environment, we don't have any slides. Everything we do, if it goes wrong, it goes wrong. So just here, one server alone in 24 hours produces statistics, 10.5 million statistics in a 24-hour period. So that's around 120, 125 changes every second on that server. So technically, do you actually know where you are? If your server's changing all the time, that many times, you don't really know where you are if you're not logging it. And if you're not logging it now, you probably weren't logging it yesterday, and you probably weren't logging it from when you first had the server. So you don't know where you are, and you don't know where you've been. And then it's very hard to judge where you're going, and that's what this use case is. It's called ITOA, IT Operations Analytics. It's an acronym in an acronym, basically. So Pete, if you could just close down this, hopefully you can see this, and if you open a new preset for me.
Where's my presets? All right.
And the key thing is about this is the ITOA is there's been actually a couple of very interesting use cases really, or examples. So if we look at TSB, they've just done a big IT transfer to a new infrastructure. There's been millions of outages, millions of users who've not been able to connect in. That was transforming from one infrastructure to another, and it's suggesting that they didn't know how to do it. And you've also had Visa recently with a major outage, and that has been part of their transformation to a cashless society. So ITOA can help you transition and make better decisions about your infrastructure. So Pete, if you can just take that average CPU there. So what you can see is here is in 24 hours, just the average CPU information is about 157,000 pieces of information in a day. And what you can see is, Pete, if you can just maybe zoom in. So that there clearly isn't 157,000 things, but Pete can just pick up a specific point here. And we zoom in. And then what we have is it's a Google Earth approach to visualization. So it gives an accurate view of what it looks like from a certain altitude, and then you can zoom in and see that extra data. So Pete, do you want to just drag and drop that particular server? So if you take the CPU information and we show the all-time information now. So this particular environment came on in Valentine's Day this year, so there's about 60 servers. Every day is about 10 million stats from each server coming in. And I believe this now, if you double click on that, so that is about 17 million metrics from one average CPU. We can drag and drop multiple ones into here. The reason I'm telling you this is because it's very important that you have the historical data and you have a way of viewing it very quickly. Again, not knowing where you've been is very important. So again, Pete, if you want an example, again, that's 16 million statistics from that CPU's entire lifespan since we inherited it. And then what this is showing you is the daily information. Again, we can just zoom in and refresh. And we can zoom in again and refresh. Get right, drill down to every one of those. You know, we can get right down into the most granular level of detail. So we've got several clients who use this platform. The platform's called mosaicOA. And we've been working now on this since about 2014. We've got multiple clients in the capital markets who use it. So if we can just jump into the certain environments we can show you on the live internet, but certain clients have they don't want to have it, so they have it from our public cloud. And what I'm going to show you here is here. So what we've got here is there's a appliance which is used quite frequently in the capital markets. It's called Solace. It's a middleware messaging. This particular client has about 64 appliances in the capital markets. And this particular view is what's called subscribers. So they've got two appliances. One's called GC5, one's called GC6. The green one is GC5, the blue line is GC6. And these are the subscribers. So they've been giving us all the information now for, this is 430 days worth of information. I think this just metric is about 1.4 million stats. And what we do is when they want to look at it, they just drag and drop it in and they can see the whole of the time ever since it came in. One of the reasons we chose Influx was actually the data and detail retention policies. So what we can do is we keep all the most granular version of the data for 60 days. And then after 60 days, we move to a minute for a further 30 days, and we keep the min, mean, and max. After 90 days, we keep an hour's worth of information, min, mean, and max. And then after about 180 days, we keep the daily information. So what happens is the data is stored permanently, it never gets deleted, and we can tag it onto new servers. And that's what we've done here. And that's important because what you've got here is actually a market swing event. This was, I believe this was something Donald Trump did. Specifically. And then if you just jump onto and when we have the photos taken, I want to look tall and thin and handsome. So we've got trend lines we've added to this data here. Now this looks quite flat and boring, but the beautiful thing is we can do is if we just jump onto the next slide, if you can just zoom in there, Pete, for the audience.
Oh, damn, one sec.
So what that is it's about 430 typical. The slides broke, everybody.
Yeah, PowerPoint broke, not Mosaic. There we go. This is beautiful.
Yeah, this is why we don't use slides at CJC. So,
unreliable companies like
so what we've done is that we're going to show you that we go into, so you can just about see it there. We're looking at the last 500 days, but what we've actually asked the database to do is we don't want to see that point where the data dropped, right? Because that was a result of this system. So if you go to the next slide, actually, so this was, it's actually Valentine's Day again. We've cut the data off, but this was what the trend line was actually looking at this stage. Now what we've got, as you can see, we've got a threshold here at 7 million. That's 7 million subscribers. Well, we know for a fact that these appliances can't handle 7 million subscribers. So we could actually see at that point there, you've got very, very clearly that this is building up over time. And you could see appliance 1 was going to crash on September the 18th at 11:58, and appliance 2 crashed on February the 28th, well, this was 2019. Incidentally, that's my wife's birthday, and that's normally the time that she crashes on her birthday too. So what we can do is, and this is the importance of keeping all the data. If you just jump to the next slide, Pete. So we've gone completely here. This is the same graph, but if we jump into the next one, what we do is we've got here is New Year's Day this year, and this was before the tuning. If you move into the next slide, if you don't keep all the data, you get a very, very different trend line. It was actually saying that the data was going downwards. So this is where, if you don't keep the information, you don't know where you've been. You don't technically really know where you are now, and you might not know where you're going. So that's why we have those keep all the data in the data and detail retention policies. So Pete, if you just want to open a dashboard there. This system's all in the cloud. A lot of clients found that ITOA is very expensive. It needed a lot of infrastructure power. A lot of capital markets participants are, the databases they use are very expensive. They get a lot of internal charging. And so when we wanted to build this system, we chose Influx because obviously it was open source and we could use the cloud, and we really got really great economies of scale. And what we found is that because we've invested into this system and we've used the cloud and we've used open source, this is now helping clients move to cloud. So the servers we've been looking at here are all physical servers, and we're helping them to move into things like cloud, that transition. So if you want to zoom into this area here, Pete. So what we try and do is, what we've noticed in all the systems is there's a lot of going backwards and forwards. You're just looking at, let's say, one server or a few servers. And what we've tried to do is make more interactive features. So what we want to do is basically say, look, what's happening here, right? What's happening in this environment? So we've just got a selection of servers here. And what this does is, this is something we called hot and cold. It's like got a performance index, and we're competing with taking stats like the memory, the CPU, the operating system, and so on. And then we're basically rating the system compared to each other. So this server here is very cold. So you can click on that one, Pete. And you can see things like the CPU information, the memory. These things are called image rates. So this is market data. So you get update rates. So that's saying that this particular server is sending around 80,000 updates per second at times. It's got 60,000 images, and we've got these amount of items. So Pete, do you want to just go into the config there?
Into the config, yeah.
And what we can do is we can do something like stacking. So this is all different types of feeds from market data. So if you go into just stacking group there, and just choose stacking group 1, and click OK.
I love it when you go.
So we can see all this in top of each other. So actually, at the same time, this has got 300,000 market data items, which equates to 6,000 images, and it's updated 80,000 times a second. But if we go to one of the warmer servers, let's say, we can actually see that CPU's increased on this server, which is relative to the others. But then we can see this is also doing 300,000, but the update rates are much higher. This is at 400,000 updates per second, and so on. So we can very quickly see how the relationship is between the different servers. And what we're trying to actually do here is this. Pete, if you just hit the names there, you can see there's different shapes in here to this data. So what we actually want to do is that we want to get all these shapes the same, because we want to know where the servers are overutilized or underutilized in relationship to one another. And the concept is if you've got 100 servers and 50 servers are overutilized and 50 servers are underutilized, well, technically you could spread the load across 75 servers instead, and you could ditch 25 servers, and this is what we've seen at clients. So a server in a capital markets participant is about $20,000 a year. So that's 500K you've saved just off 100 servers. Just give me a second. So what we found is, I just got to here, is that some of the things that we've been able to do. Again, we've just talked about the significant hardware reduction, the transition from one place to another, to the cloud. And we had a major use case last year, which was the Intel meltdown. And this is where we found this great marriage between ITOA and DevOps environments. And so a lot of work. I don't know if you just want to minimize that, Pete. And if you open up the asset manager. So we just jumped from a client in London. This is a client in Chicago that we have. If you just go into the KIMP PCA here, what we'll see is you can see that very quickly in a second, the QA, UAT and dev is used much more than the production environment. That's typical at most institutions, and you can see in the relationship there, again, we've got that hot and cold index, that the dev is much more utilised than the production. And this is where we found that you can really start testing what's going to happen. So when you had the Intel meltdown patch, the client had no idea what impact that was going to have into their infrastructure. So they rolled out the patch in QA, they could see problems. If you just click on error analysis there, they can then go and search and then in effect replay what's going on, and then they can sort of roll back the patch, then try it again. So that again, you've got the date and time there, Pete. If you just want to change the date, just pick a date as you wish. You can say, like, look, just go back to the beginning of this month, click go. So now this will just show you the error messages which are going on. You can get it right down to when you rolled out that patch and keep on just doing the analysis there. If you just want to go back to the main dashboard, the previous one. So if you just click on tab 2 there, Pete. So what's developed is a concept I like to call human machine learning. And this is where, because the users have not, like we're living in an age now with AI, self-driving cars and things like that. The human beings kind of like with our confirmation bias and human error and whatnot. But really, before, we've never had this kind of information. And generally, we've had engineers who've had theories about what's been going on in their infrastructure, and they've never been able to really prove these theories because they've never had the data. So this is a case of where the human machine learning, actually the feedback we've had from clients have come up with some really great ideas. So some of those screens we've shown before has just been basic CPU, but a lot of things is like thresholds. A lot of clients talk about thresholds, but thresholds change all the time. And I don't know if you want to pick one of these servers like at random here. So what we've got is, this is a great example here. So this purple view here is what's happening today. This is this CPU right now. And then the green shape in the background is what that CPU normally does every day. Because what's happened is, a client went to me, I don't know if my CPU's at 70%. Is that good or bad? Right? Because it changes at different times of day. And you're in the capital markets, you have like the US market open, you have market swing events, spikes, news announcements, and so on. Sometimes you want to know what, yeah, it's at 60% because it's normally at 60%. Or then all of a sudden you've got, that is something which is unprecedented. Even though it's not much, it's only at 7.5%, it's fairly unprecedented. So Pete, if you want to zoom in on that. So this is something where a client really needed to understand what was happening in the system at a certain time of day. So we can we zoom into that, Pete, and then maybe you want to minimize it. And what will happen is it'll zoom in on all the other screens as well. And this is where we've been able to devise this human machine learning. So the humans can understand the machines better, they can make better decisions about what's going on in the infrastructure. And yes, they can then inform their machine learning tools as well. Pete, if you just want to go back to the previous screen, you can see here that we've got tabular views. We've got views which are just reading files, like to tell you what uptime is and so on. Yeah, if you just want to zoom into that area there, Pete.
Please hold. It's the laptop.
Yeah, it's the lack of slides.
That is zoomed. That is zoomed. I zoomed while you was
no, into the, if you click on the button.
Oh, what?
Yeah.
That. Or the actual
Yeah.
zoom. There you go.
So what I'll do is just for a quick second, I'll jump. Is there any questions anybody's got?
How do you compute the baseline, like the previous, like how do you know what your green graph looks like?
Yeah, so what we do is because we keep the information for all time, we can then review that, and then that's done intelligently. So what we've got is a process which we call CIM, which is Correlated Input Matrix Process. So all that information is stored in InfluxDB. And then what we do is that we look at the shape, so we can actually, Pete, if you just want to go into the config there. And then what we've got is that showing the background shape of the data over 7 days. But what you could do is there, Pete, is if you just change it to the last 30 days. And then click OK. So this will change that background shape. So potentially we can have it all time. This is what's happening all time. Or there could be the fact that there's, okay, we've seen an issue now, we fixed that issue, let's change the shape of that background data. But all that data comes from InfluxDB, and then we just have a process which runs on top of it. So what we do is we have a secondary database which creates. So it looks for certain thresholds and things like that. We create a new database on top of the original database where all the data is stored, and that's where we pull our information from as well.
So it's
So
important.
yeah, so this background shape change, but Pete, if you just want to zoom in with the feature there. And if you just minimize the window down, again, you can see that spike again there. And what's actually happened is so if you move the mouse along, just when it comes in. So if you zoom in again. And what you've noticed is all the other windows have changed at the same time. And that's where we talk about impactful visualization. So what you've got is you can quickly see what's going on in the environment. You can jump between, so you don't have to go backwards and forwards. You can quickly see what's going on, and then you can just click on that server, and everything around that server changes. You can see everything from a tabular format. You can change the date. And then what we can do is when we see something of interest, we can zoom in. So if you just want to try that again, Pete, just zoom in again.
We zoomed already.
Yeah, just with the function.
It's not letting me do it.
Just try clicking on it,
Yeah,
because sometimes it doesn't bring up the window. But yeah, when you zoom into that, it'll correspond with all these other things, and you can see as Pete's moving the mouse along, everything syncs up, so you can see what impact, what was causing that CPU spike, what's causing. Sometimes it might not show anything there, but then you can say, look, something caused that CPU spike, what actually caused it. Then you can go to another part of the system and then look at all the events which were going on in that moment to figure out what was actually happening on your system.
It's probably important as well to point out that obviously live demo, real data, we don't pre-cache. So we go away, we call it every time. When it's this, you know, the KIMP stuff, all of the calculations about the highs, the lows, the average, the little dotted predicted line about where it thinks it will go, that all happens kind of as you pull it. So the idea is that we don't ever really know what the users are going to want to look at, so there's no point pre-caching. That's why the persistence engine in the background is built to make it very efficient for when we call the data and then allow you to zoom into the areas that are interested to you. So it all comes in fresh every single time you open a new analytic.
The interesting thing, you talk about baseline here, but these things here are application level statistics. So this ADS is an advanced data server. This is what sends the market data down to, you know, sort of banks all across the square mile. And these are key things. You know, there's a lot of things which are happening inside the application which is affecting things like the CPU and which could be having consequence on other servers. One thing we're actually doing is that obviously you've got, in this particular environment, you've got 60 servers. So we've got a snapshot of these servers. So these are the kind of south side facing servers, not the north side servers that clients don't connect to. But so we can separate these away from the two sides of the infrastructure. So we've just got a snapshot here which are relevant to a particular part of that infrastructure. But potentially, instead of showing all these separately, we can combine them all into a single line. So we can see what's happening on multiple servers at the same time and scale that growth. And again, it's the same concept. You can go right back to day one when the data started coming in. Has anybody else got any other questions at all?
That's it.
Okay.
No questions.
Great stuff. As I said, that's mosaicOA. Hopefully that you found it informative, and we're happy to communicate and tell you how we've done things, you know, and be part of the InfluxData community. So, thank you very much. Sorry, I know we've got 10 minutes remaining there, so a bit quick. Yeah.
What do you use to collect the data? Did you guys write your own Telegraph plugin, or it's just your own stuff?
Yeah, so we built this system going back a few years. So we've been doing visualizations. So CJC is a managed services company. We've got 500 clients globally. We're operating in the capital market. So we started this journey. We were doing visualizations around infrastructure back in 2010. And we were using various other databases at the time, things like MongoDB and so on. So we started to build this. We could see where ITOA, what it could achieve for us. And that's where we started the journey with InfluxDB. So this is going back to 2014, 2015. And we've been starting to build this. We've worked with, obviously the front end is from, we've worked on, and it's something we've internally developed. But what we do is we do actually use those tools as well. So yes, the use case is ITOA, but then we're a customer, of Influx. So sometimes in the database there could be a particular event or something that we need to look at. So that's where we use Chronograph, and Influx looks into that data. We can actually, with our system, the data looks exactly the same in our system, but obviously the third line vendor wants to use those tools. Yeah. The thing about the capital markets is it's a very unique, we're just going through, we're just putting an infrastructure into Azure for a client, and they're like, there's 4 databases you can use at that bank, and you have to go up front if you're using an open source system. And there's very, very specialist plugins. So you've seen things like Kafka and things like that. But all this data is derived from a monitoring system that it's called ITRS Genios in this particular use case. And all the data is coming from a very, very specialist system. And so we've had to respite the bespoke collectors. And then the clients have certain ways that they want to see the data, which are very unique to the capital markets. So and what we do is, this isn't just a piece of software, isn't just a front end. We have to provide a whole holistic solution. So we have a platform, we can walk to our data center, it's just up the road. But we're in Equinix in LD5 and 6, which is kind of like the Grand Central Station of the capital markets community. And a lot of clients are very anti-cloud at the moment as well. So we come in and we can provide an environment in a secure, well-known financial location. We can orchestrate that just like we do in the cloud as a cloud provider. But then we handle things like the infrastructure, the database support, the database rights. We handle the collectors, we handle the dashboards and everything. It's a holistic solution, because generally when you've got ITOA, you might need a team of 13 people on a site just to do that. So clients in the capital markets want to outsource, and that's where they've come to us to have this holistic solution.
Good, Steve. Appreciate it.
Thank you. Cheers.